In this video, I want to use OscerSyn to explore some simple enolate chemistry. This will be all stuff that we've done in class, so it'll serve as a quick review, and it'll also show you how to use OscerSyn. So here I've started with cyclopentanone, a simple ketone. It's symmetric, and let's just see how we can make do some alkylations on this molecule. So I want to start off by forming an enolate. The easiest way to do this is go up here to our reagent chart and let's choose LDA. Now LDA is a very strong base. It's a hindered base. It's very good at forming lithium enolates. So we'll set up our reaction, press the reaction button, and what we have, of course, is the lithium enolate. Now here it's a symmetric ketone, so you could take a proton off either side. It doesn't matter. But we get this nice lithium enolate all set up to do an alkylation. So I just need a reaction arrow and a alkyl bromide. Let's do something simple. We'll just do ethyl bromide and see what we get. We of course get the ethylated product. Now this is a monosubstitution. What if we wanted to put a second group on? Well, let's just do the LDA reaction again. So go up and I'll grab another mole of LDA. Put in a down arrow here. This should make us a new enolate. But now look at this. We had a choice. We could go to one of these two protons from the left off, or we could get this one at this already substituted center. Now, the one that LDA chose is the one to the left. Why? Because it's sterically the most accessible. And LDA is a huge base, lots of steric blockage, and it'll always go for that proton which is the most exposed. The one on the other side actually might be more stable, but this is the one that's kinetically favored. But we have this new lithium enolate, and we can do a second alkylation. So let me draw another reaction arrow. Okay, and I need a new bromide. Let's do something a little more complicated. I'll put a benzyl group on there. So here's a phenyl, and draw in a carbon and a bromide. Okay, and what do we get? We get now the di-substituted ring. So here we did two successive alkylations. They went on opposite sides of the ketone. What if we wanted to put the second alkyl group at the same carbon? Now here we have to use a trick because the lithium won't form that enolate. But what turns out what you can do is you can form instead of forming an enolate, you can form a silyl ether at that position. And the way you do this is that you use a TMS. So you get the TMS from the menu up here. Here's the TMS. We need to use it as the chloride. Now this is trimethylsilyl, and for the trimethylsilyl reaction to work, we need a weak base, and the base was usually used as triethylamine. So here's our triethylamine. So what's this going to do? Well, the oxygen is going to attack the silicon, kicking off the chloride, and we'll end up also losing a proton, which the triethylamine will grab. So this will give us our silyl ether. Now this is of course not an enolate; it's an ether. So and it turns out it's not easy to alkylate these things. You need to turn it into a real ether. Well, there's a trick for doing this, and you can turn it into the lithium enolate. And the way you do this is that you attack the TMS. What likes to attack the TMS? Well, one thing you do is you can methylate it, and you can make tetramethylsilane. And the way to do that is to use a mole of methyl lithium. So I'm going to draw an up arrow here and draw in a methyl lithium. So here's a methyl, okay, and a lithium. And if I do the reaction, there are new enolate. Now this enolate, compare it, the one up here to the one down here. This is what you'd call the kinetic enolate. This is the thermodynamic enolate. And it's all set up for a final alkylation. And what shall we do? Well, let's just do something simple. We'll put a propyl group on there just for the sake of argument. So here's a propyl group, and this will be our di-substituted compound. So there we put on two substituents on the same carbon. Down here we put them on the opposite carbon. So I hope this gives you an idea of how to do these syntheses. It is pretty simple, and I encourage you just to go into OscerSyn and play. Just make up your own ketone, try your own alkylating agents, Try making the enolates in different order, see what you get. And I think you'll learn something, and maybe you'll even have a little fun doing it.